Good morning. Today in Math 111 we're going to talk about section 2.3 in our text entitled Slope of a Line. Now, of course, from our previous courses in algebra we all know what slope is. Well, slope really in essence is a number that gives a numerical measure of steepness, or the degree of steepness of a line. And let's say if we've got a coordinate axes and I draw some unspecified line in this coordinate axis, and I'm going to label 2 points on this line. I'm going to label one point x sub 1, y sub 1, and I'm going to keep those coordinates unspecified. Let's say I've got another point here I'm going to call x sub 2, y sub 2. What I'm going to do is define what I call a slope formula. Slope, well, we reserve the letter m for slope. M is the evolution of the letter m is from the French verb monter. Er ending indicates a verb, and monter means to climb in French. It is the verb to climb in kind of a descriptive way, and in some ways a descriptive symbol to describe slope. Alright, let me erase that and so I get room for some numbers here. So my slope I'm going to determine is defined by the formula y2 minus y1 over x sub 2 minus x sub 1. And of course you're thinking, well, that's nothing more than the difference of the y coordinates divided by the difference in the x coordinates. You're absolutely right. If I was to draw here what I call a slope triangle, I can visualize, let me put the coordinates up here, x2, y2 of that second point. Well, the difference in the y coordinates here can be described or visualized as the vertical distance between those points in the xy plane. Similarly, the difference in the x coordinates can be visualized as the horizontal distance between those points in the xy plane. Now I can I can indicate that the difference in y coordinates, I could call that the rise between any 2 points on the line, and similarly I can indicate the difference in the x coordinates is the run between any 2 points on that line. Hence the sometimes little less formal expression, your slope, can also be described as rise over run, and I'm sure you're familiar with this symbology also. M is your change in y over your change in x between any 2 points on the line. Alright, so slope should not be a new concept in any way to you, so let's dive right in and do some slope calculations. Find slope of line through the following 2 points, minus 2, comma 4, and 3, comma minus 4. Well, I don't really need to graph these points to compute the slope. What I usually do is let the first point mentioned be x1, y1, and the second point mentioned be x2, y2. Of course, you could label these points in any way you like, and it'll all come out in the wash. Well, if my slope is y2 minus y1 over x2 minus x1, well, that turns into a negative 8 divided by positive 5, so the slope of this line is a minus 8/5. Let me sketch this line quickly, get some visual interpretation of what's going on. Let's see, the first point given was -2, +4. Again, I'll do the best I can without graph paper here. And if x is 3, y is -4. Puts me down here. Let me label these coordinates, -2, 4, and 3, comma, -4. If I connect the 2 points with the line, I can show the line that goes through those points. And if I draw now what I call a slope triangle, really break up the path between those 2 points into horizontal and vertical components, well, I can see that my x value goes from -2 to +3. That indicates a positive change or a positive run of 5, as indicated by that denominator in my slope calculation. Similarly, I can look at the y-coordinate. Well, the y-coordinate goes from 4 to -4. That's a drop of 8 units, and a drop translates into a negative rise. So I can see that my rise in this situation would be a -8. So my change in x is +5, my change in y is -8, and is indicated by that negative fraction calculation for my slope. Alright, one thing I want to highlight here is negative slopes. If your slope is negative, essentially that means your line is going down left to right. I call that a decreasing line. So if your slope is negative, your line is always decreasing, again, in a left to right sense. Negative slope, decreasing line. Let's do another one. Find slope of line through, give you another 2 points here, -4, -2, and 2, comma, 4. And again, we don't really need to graph the line, but we can compute the slope. My slope will be, well, again, change in y over change in x. You don't have to formally label these as I'm doing here. Well, I'll say y2 minus y1 over x2 minus x1. Be careful of the signs here. In the numerator, 4 minus -2 is +6. Downstairs, 2 minus -4 is also +6. So I see my slope reduces to the value of 1. Slopes can be whole numbers, slopes can be fractions, slopes can be negative whole numbers, negative fractions. It depends on the steepness of the line. Alright, so if my slope is 1, well, let me see if I can graph this quickly. We want to go from -4, -2 to 2, comma 4. Let me see if I can get a good picture of this here. So my y-axis, my x-axis. I go from, let's see, if x is -4 and y is -2, puts me here. And then if x is 2, y is 4, puts me here. Alright, so if I draw a line connecting these dots, doing the best I can here without graph paper. Alright, we can easily see, well, let's see, the coordinates of this point here is -4, comma, -2. The coordinates of this point up here is 2, comma, 4. I can see again, my x value goes from -4 to 2. That is a change of +6. Is my horizontal distance between those 2 points. Similarly, my y value goes from -2 to +4. Well, that's also a change of 6. So I get a rise of positive 6. So here my run and my rise are both positive 6. So of course my slope is going to be plus 6 over plus 6, which of course equals 1, equal to what we got with the slope formula. Alright, this slope is positive, right? Slope of 1 is a positive 1, and when you've got a positive slope, that means you've got an increasing line. That means increasing left to right. Positive slope, increasing line. Negative slope, decreasing line. Alright, so we've done some slope calculations, a couple of special cases here. I want to talk about horizontal lines. Well, let's graph a horizontal line, see what it looks like. Let's say I want to compute the slope of a horizontal line. Let me graph one first. Well, I'm having trouble drawing a straight line here. Bear with me here. I'll try it with a ruler. Sometimes this works okay with the tablet, sometimes not. Oops. Alright, very good. Hang on, I'll erase those in a minute. Yeah. Hang on a minute. Try again. It's difficult using a ruler on the tablet. Try one more time. If this doesn't work, I'm going to do it freehand. And there's the y-axis. And here, the x-axis. Alright, looks better. Y-axis, x-axis. Let me erase some of these extraneous marks. If I've got a horizontal line, I'll graph it in green here. Let's say I've got a horizontal line it seems to work pretty well. Alright, let's say I want to compute the slope of that horizontal line. Now, I hope you'll agree with me when I say there is no rise. There is zero rise between any 2 points on this line. Well, if I was to blindly plug in my slope formula into my slope formula, I would then get, well, if I look at my rise over run, it really doesn't matter what my run is. My rise will always be 0. There is no rise in a horizontal line. And if a numerator has a fraction has a numerator of 0, well, that means the fraction itself is equivalent to 0. Well, the moral of the story here is if I've got a horizontal line, my slope is 0. So let me write that down. Horizontal lines will always give you a slope equal to 0. Now 0 is a number. It exists on the number line. So don't confuse it with undefined slope that we're going to talk about next. Horizontal lines, 0 slope. Okay? Let's talk about vertical lines. Vertical lines. Well, what do vertical lines look like? Let me try to do one here. I'll do this freehand. It takes too long with the ruler. Alright. Let me draw a vertical line. I'll put it in red. This is a vertical line. Okay? Alright, what happens in a vertical line? Well, there is no run. Between any 2 points on the line, the run will equal 0. Right? Well, my slope, recall, is defined as your rise over run. And, well, in a vertical line, it really doesn't matter what my rise is. between any 2 points. The run will always be 0, and division by 0 is undefined. Now, undefined is not a number. It does not live on the number line. So in the case of a vertical line, I'll say we have an undefined slope. Some books may say infinite slope, and I suppose that may be more descriptive. A vertical line is all rise. There is no run, hence the possible interpretation infinite slope. All right? Get a fresh screen here. Again, a horizontal line always has the form, or can be reduced to the form, y equals constant. And if y equals constant, there is no change in y. Hence, m equals 0 over whatever your run is, and your slope equals 0. So horizontal line, y equals constant, slope equals 0. And again, vertical line, well, vertical lines can always be reduced to the form x equals a constant, and if that is true, there is no change in x. Hence, there is no run. So it doesn't matter what your rise is between any 2 points. If your line is vertical, you've got no change in x, no run, and undefined slope. Okay, so another way to look at horizontal and vertical lines. Horizontal lines, 0 slope. Vertical lines, undefined slope. Please try not to confuse those two cases. Okay? Alright. How about parallel lines? Alright, parallel lines. Well, what's the definition of parallel lines? It's lines that never intersect. Let me try to draw, at least approximately, a pair of parallel lines. Let's see, I know what to do. Hang on a minute, I'm going to try the ruler again. I can do this with both sides of the ruler, right? The ruler moved. Alright, I think we get the idea. L1, I'll call the top line line 1. I'll call the bottom line line 2. And I'll claim L1 is parallel to L2. Right? Parallel means the lines never intersect, and I think you'll agree with me, if lines never intersect, that means the ratio of rise to run must be the same between any 2 points on that line, and if the ratio of rise to run is the same, that means the slopes are the same. So if line 1 is parallel to line 2, then the slope of line 1 must equal the slope of line 2. In other words, parallel lines have equal slopes, but I'm betting that you already knew that, right? Parallel lines have equal slopes. Perpendicular lines is a little more complicated. What about perpendicular lines? Well, let's see. Let me draw, well, perpendicular lines, let me define that first. They intersect at a 90-degree angle. Alright, so if I was to draw a line here, and if I was to draw another line here, and I think we can envision them intersecting at a right angle. Alright, I'll call those two lines perpendicular. Alright, let me call this line line 1 and this line line 2. And let me get a visual approximation of the slope of this line, line 1. I'm going to claim that line 1 has a slope, well, I'm going to call it a third. Let's call it a third. I'll say my run between these 2 points is positive 3, and my rise between these 2 points would then be positive 1. So I claim the slope of line 1 is 1/3. So m1 equals 1/3. Alright, now if these two lines are perpendicular, if L2 is perpendicular to L1, let me say this: perpendicular lines, well, they have negative reciprocal slopes. And what does that mean? Well, it means just what it says, really. They're both negative and reciprocal. So what's the negative reciprocal of 1/3? Well, if I take the reciprocal of 1/3, it's 3. So the negative reciprocal of 1/3 would be then negative 3. So if I embrace this negative reciprocal here, that means the slope of line 2 would be the negative reciprocal of 1/3. All right, so please convince yourself that 1/3 and -3 are negative reciprocals of each other, and if slopes are negative reciprocals, then we know the lines are perpendicular. Okay? Again, to refresh our memory, parallel lines, parallel lines have equal slopes perpendicular lines have negative and reciprocal slopes. Negative reciprocal slopes. Okay? Alright, so nice test for if lines are parallel or perpendicular. Alright, you may be familiar with Regents exams questions such as this. Are the two lines given perpendicular, parallel, or neither? You'll remember these questions like this. Let me give you two lines, and I'll give you them in terms of coordinates. I have got a line through -2, -2, and -5, 4. Alright, let's give you another line here, different line, through -6, 2, and -2, 4. Well, I'm going to ask you then, determine if these lines are parallel, perpendicular, or neither. Alright, well, if they're parallel, the slopes will be the same. If they're perpendicular, the slopes will be negative reciprocals. So all I really need to do is compute the slopes and compare. Let me look at the top line first. The slope of the top line is going to be y2 minus y1 over x2 minus x1. Be careful of these signs here. So in the numerator, 4 minus -2 is 6. Downstairs, -5 minus -2 would be a -3. And 6 over -3 is -2. All right, so the top line has a slope of -2. Okay? How about the bottom line here? Well, let's grind it out. My slope of this second line, y2 minus y1 over x2 minus x1. In the numerator, 4 minus 2 is 2. Downstairs, -2 minus -6 is 4, is it not? 2/4. And 2/4 reduces to, of course, 1/2. So I'm going to say my second line has a slope of positive 1/2. So computing the slopes for those two lines, I get -2 and 1/2 respectively. Well, I can now make the judgment. Are these lines parallel? Of course not. The slopes are different. Are they perpendicular? Well, if they're perpendicular, the slopes must be negative reciprocals, and indeed they are. Right? 1/2 is the negative reciprocal of -2, and the negative reciprocal of -2 is positive 1/2. Right? So I claim perpendicular should be the answer to this question. Perpendicular. Okay. Negative reciprocal slopes. I have shown that the slopes are negative reciprocals, and if that's true, the lines must be perpendicular. Okay? Alright, I want to run through some of the harder homework type problems. Let me get a fresh screen here. Let's see. Find slope of line through the following 2 points. 1/4, 9/2, and -3/4, comma 0. Now we try to stay away from fractional coordinates if we can. Well, we can't always. Sometimes you're forced to deal with them, like in this example. Alright, well, if your coordinates are fractions, you're going to have to use coordinates or fractions to compute your slope. Again, I would probably label this x1, y1, this point x2, y2, and say my slope is then y2 minus y1 over x2, and let me try again, y2 minus y1 over x2 minus x1. Now, students tend to panic in problems like this and lose really points that are not too difficult. All right, let's take it a step at a time. 0 minus 9/2. Well, 0 minus anything is just going to be minus anything. So minus 9/2 appears in my numerator. How about downstairs? -3/4 minus 1/4. Well, those denominators are already the same, so I can just add or subtract the numerators as indicated. So I've got minus 9/2 on top and -4/4 in the bottom. Minus 9/2, I can't reduce that very much, but downstairs -4/4 reduces to a -1, and when I divide a fraction by -1, it's like equivalent to multiplying by -1, really. So I'll get minus 9/2, really the negative of -9/2. I get positive 9/2 as my slope calculation. Alright, so even with fractional coordinates, I can compute a slope hopefully without too much trouble. Alright, so don't panic when you see problems like that. Tough it out and you should be okay. Let's try another one. Find slope of line through -6, -4 and 3, -4. Alright, we could blindly go through the slope calculations, but I'm hoping that you'll notice something in these 2 points. Does anybody out there notice anything about these 2 pairs of coordinates? The y values are the same. Right? And when y values are the same, that means between those 2 points, y is constant. And if y is constant, I've got a horizontal line, do I not? And if I've got a horizontal line, that means my slope is 0. Horizontal lines always have a slope equal to 0. Let's say I didn't notice any of this and I go and plug into my slope calculations y2 minus y1 over x2 minus x1. Notice there'll be a cancellation in my numerator. My numerator will turn into a 0. It really doesn't matter what my denominator is. My slope reduces to a slope of 0 in my slope calculations. Alright, so probably better to use a little finesse and notice things like that before blindly plugging into the slope formula calculations. Let me try another one. Find slope of line through, let's try it, -7, 4 and -7, -3. Again, well, you probably noticed something because I just talked about this last example. Of course, you'll notice these x coordinates are the same, the y coordinates are different. Well, that means x is constant between those 2 points on the line, and if x equals a constant, that means you've got a vertical line. X equals constant vertical line, and vertical lines always have what we call undefined, or some call infinite slope. Vertical line, undefined slope. So probably best to notice by inspection these x coordinates do not change. You can instantly write down your response, undefined slope. Alright, if I didn't notice that, I could probably go to my slope calculations. Y2 minus y1 over x2 minus x1. See what happens? The numerator reduces to a minus 7, but the denominator, those terms cancel each other out. And I've got division by 0. Division by 0 is undefined, hence the solution undefined slope. Okay? One more, we'll call it a day. Find slope of line through. Let's see. Now these coordinates are a little too much to graph, but I don't really need to graph these lines if all I want to do is find the slope. Alright, my slope. Again, I'll let the first point be x1, y1, the second point be x2, y2. It really doesn't matter. You can label these points in any order you wish. Y2 minus y1 over x2 minus x1. Alright, I've got to use my signs correctly and simplify correctly. 17 minus 50 in the numerator is a minus 33. And 7 minus 28 in the denominator is going to be negative 21. Now negative over negative is positive, and 33 over 21 reduces, does it not? 3 goes into both numerator and denominator, so I think my final solution for the slope would be positive 11/7. And again, no mixed numbers please, no decimals please, we really don't need them, and my slope here reduces to positive 11/7. Alright, we'll call it a day. This concludes lecture, online class 2.3, slope of a line.